So today we're going to cover additional characteristics of quadratic functions. So before we get into the lesson, let's just review what an intercept is. Now, back when we did linear functions, we knew that the intercepts, we learned how to find the x and the y intercepts, and we found them by plugging in zeros. Now, in today's lesson, we're going to find the x-intercepts by just looking at the graph. And remember, on your coordinate plane, the x-axis is this way. This is x. This is y. So we're going to be looking to see where does our graph intercept the x-axis. Now, sometimes it won't hit it. Like, for example, if your parabola was up above, then it wouldn't have any x-intercepts. But if you're just given an equation, to find them, you're going to set y equals 0, and then you're going to solve. So, for example, on number 1, if you wanted to find the x-intercept, you're going to make y equals 0, and then solve the equation for x. So we would add 3 and get 3 equals 2x. Divide by 2. And our x-intercept is 3 over 2. And that's how they got that. So when you're finding the x-intercept, replace y with 0 and solve for x. Now, if it's asking you to solve the quadratic for given values, we really did this yesterday when we completed the tables. Again, when you're solving or evaluating each quadratic equation for a given variable value, like for x equals 2, every time you see the x, you are going to replace it with the number 2 and then follow PEMDAS. So here, my equation had an x here and an x here. So again, I'm going to follow order of operations. I'm going to do the exponent first. And then I have 2 minus 2. So now I'm going to multiply second. And now I only have addition and subtraction. So I'll work left to right. Negative 12 plus 2 is negative 10. And then minus the 2 is negative 12. So if you are asked to evaluate a quadratic function, you just replace the variable and then follow order of operations. So this is just a review. So our objectives in this lesson are going to be, they're going to ask you to find the zeros from its graph, find the axis of symmetry, and the vertex of the parabola. Now, the zeros, and this is what confused a lot of my students in Algebra 2 last year. They're going to see this question asked in multiple ways. They're going to ask you to find the solution. They're going to ask you to find the roots. They're going to ask you to find the zeros. But for us, we're just going to find the zeros. And in today's lesson, you're going to be given the graph of the parabola. And we're going to just look to see where does our parabola cross the x-axis. The axis of symmetry is going to be the line of symmetry that you could draw through your parabola. And it would fold the parabola so that the sides would match. We already saw how to find the vertex yesterday. It's either the highest point or the lowest point. So here are 2 vocabulary words, and we're going to see these in action in a minute. So here it says, recall that an x-intercept of a function is a value of x when y equals 0. I just showed you that in the warm-up. So to find the x-intercept, you're going to make y equals 0 and then solve your equation. So finding the x-intercept is the same thing as finding the 0 of our function. Now, our quadratic functions may have 1 0, 2 zeros, or no zeros. And I'm going to show you what I mean by this. Okay? So, I'll just draw it here, give you a quick sketch. When it has 1 0, this means that the u is going to sit right on the x-axis. When it has 2 zeros, that means that the u is a little bit lower. And when it has no zeros, that means it's going to be up above it. Now remember, all of these could also have a negative a value, and they could be the upside down u's. So here it could also be this way or down here. So here is an example. It wants us to find the zeros of the quadratic function from the graph. Now, later on, we're going to be factoring this. So the same thing you just took the test on, we're doing again in this chapter. And by factoring it, it's going to give us the zeros. But right now today, all we're going to do is look at the graph. What numbers does it hit the x-axis at? Okay, so it hits it right here at -1, and it also hits it here at 3. So you would say that the zeros of this quadratic function are -1 and +3.
And later on they will give you equations about it?
Yes, that's going to come in another lesson, and we're going to cover that. But for right now today, finding the zeros, we're just going to look at the graph. Now, one way that you can do this to check it is you would plug in those values. If it ends up equaling 0, then you know you've chosen the correct zeros. And what I mean by that is you're going to take your equation, x squared minus 2x minus 3, and we're actually going to do this twice. We're going to do it for the first 0 that we found, and we're going to take out all of the x's, and first I'm going to put in a -1.
Why -1?
Because that was the 0 we found, and then the other 0. So this is just a check to see if you've correctly found them from the graph. You don't have to do it. For most of these, it's going to be very obvious. All you have to do is find the number where it crosses the x-axis.
Well, how about 3?
We're going to do 3 also. We're going to do it twice.
Oh, they both have to end up at 0.
Yes. Okay, so once I do this, I get 1 plus 2 minus 3, and 1 plus 2 minus 3 is 0. That one checked out. We've got the correct 0 on the left side. Over here, 3 squared is 9. -2 times 3 is 6. Minus 3 is also 0. So this one also checks out. So we did find the correct zeros. It is -1 and 3. Okay, so it's just a check. Yes.
So what would our answer be?
-1 and 3. So that would be your answer right here. Yes, Paulina.
So if like it didn't equal 0, what would you put for it? Would you just put like that it's not a quadratic function?
No, then you'd have to go back and double check it. It is a quadratic when it looks like a U. So maybe you said, oh, wait a minute, this looks like it's on 2. And you said, oh, this number should be 2, when you really didn't count right, and it should have been 3. Make sense? So it's going to be obvious when you're given a graph. You just got to look at the numbers correctly. Let's look at another one. Where is it touching my x-axis? At what number? Okay, at -4. Everybody see that? This is the only place it's hitting it, right here, because it's sitting right on it. Okay, so this is an example where there's only 1 0. The previous example had 2 zeros because it crossed it twice. And again, you can do the check. You'll replace 4 into the equation that's given, or -4, and you'll follow order of operations. So -4 squared plus 8 times -4 plus 16. So -4 squared is 16. Positive 8 times -4 is -32. And then you'll add all this up, and it does give you 0, so it checked. So we did find the correct 0, and it's -4. Notice the coordinates of my vertex right here, this point, is the ordered pair -4, 0. When the vertex is sitting on the x-axis, The 0 is just the x coordinate. Let's try another one. Now, notice that one only had 1 0, and that's when the x coordinate of the vertex is sitting on the x-axis. Or it's just going to be the x coordinate of your vertex. So, if we go back to that before, all right, so it says when there's only 1 0, what this means is the graph is sitting on the x-axis. So let's say this is the order pair -2, 0 for my vertex. Then the 0 is just this number. So when the vertex sits on this line, then your 0 is just this number. But if you're given a graph, you can just count the lines too and see where it is. Does that make sense? That's what they were just trying to explain in the helpful hint.
What do you mean like the 0 is?
The zeros are going to be the number where it hits the x-axis.
Oh.
So see how this one is touching the x-axis right here. So the zeros are where it hits the x-axis because it's when y equals 0. And notice in my order pair here, -2, 0, this is x, this is y. So the zeros, meaning y equals 0, when y equals 0, that's going to be the zeros for your function, the x value. Let's look for this one. Where does it hit the x-axis? Does it hit the x-axis at all? Here's my x-axis right here. Is it touching this? No. So this is an example where there are no zeros. Okay? So this has no zeros. It does not touch the x-axis. Yes?
I don't understand
So then this one, it never touched the x-axis. It's touching y, but not x. So this one does not have any zeros. Here's another one. Notice this one again is not crossing the x-axis. So there are no zeros. This one, what is the 0 of this function? Where does it hit? 3. So you would say the 0 is 3. And if you wanted to do the check, you would come up here and put a 3 here and a 3 here and make sure it equals 0. But again, when it's a graph, you're going to clearly see it. Now we're going to talk about the axis of symmetry. So sort of think of lines of symmetry, and it's going to be the vertical line, so up and down, that divides a parabola into 2 symmetrical halves. The axis of symmetry always passes through the vertex. You can also use the zeros to find the axis of symmetry. The shortest way to do it is it's going to be the x of our vertex. And we're going to see this. So here again, before we move on to the axis of symmetry, actually we can do this. Notice the axis of symmetry is always going to be the x of our order pair, and it's an equation, x equals. Now, what they're telling you is you could find the zeros and you can find the average of them. So you would do 3, there's only one number, so you would just say that the axis of symmetry is x equals 3. But if you have 2 zeros, like the -4 and the 0 here, you add them and divide by 2. Yes?
If you had something like 3, 2, would you put like 3 if it's x?
Say that again?
If it was like 3 and 2.
The order pair?
Yeah.
Uh-huh.
Would you put 3?
For what?
For the
Axis of symmetry?
Yeah.
The axis of symmetry would be x equals 3. Yes.
So it's like where it meets x.
So it's where the where the vertex is. Not where it hits the x-axis. It's the vertex. So notice the vertex here is down here. So let's figure out this order pair. -1, -2. So it's -2, comma, negative 4. So my axis of symmetry is just this number, x equals negative 2. Now what they're telling you you can also do is take the zeros. So 4, negative 4 plus 0, and find the average. So divide it by 2, because you're trying to find the middle. And then get negative 2. And it's always an equation because it's a vertical line. So don't just tell me it's negative 2. You have to write it as x equals. Let's see another example in a minute. All right. First of all, what is the 0 here?
1. No, negative 1.
Negative 1 is the 0. So the coordinates, what are the coordinates for my vertex?
Negative 1, 0.
Good.
Negative 1, 0.
So the vertex is negative 1, 0. The 0, in this case it's only 1, is negative 1. And the axis of symmetry is x equals negative 1. So if I were to draw in a line of symmetry here, it would split this into 2 equal halves. Let's look at this one. What are my zeros? Okay, 1 and 4 are the zeros. Everybody see that? This is 1, this is 4. So those are my zeros. To find my axis of symmetry, I could do 1 plus 4, divide by 2, and I get 5 over 2, or 2.5. So my axis of symmetry is an average of my zeros. Or I can figure out the coordinates of this vertex, and this would be 1, 2, 2.5, 2.5, comma, 1, 2, 3, 4, comma, 4.5. So my axis of symmetry, bless you, is this. So it's x equals 2.5. Is this vertex a minimum or a maximum? A maximum. What's the maximum value? 4.5. Good. What's the domain of this?
All real numbers.
Beautiful. All right. Okay, remember, domain is always all real numbers. The range is going to be this number, and it's y is less than or equal to 4.5. This is a review of last night's homework.
Why is the domain all real numbers if it can't surpass 1 and 4?
Okay, but that's just where it's hitting the x-axis. Notice the arrows on the end of my graph. This means that this is going to keep on going and get wider and bigger, a bigger and bigger U. Okay, or actually upside down U. So the arrows on the end indicate that it's going to keep on going. My graph is only so big. All right, let's try another one. I'll go back. Next example. What are the coordinates of my vertice or of my vertex?
Negative 3. So, yeah.
Negative 3, 0. Good. All right. What is the 0? There's only one. Negative 3 is the 0. Is this vertex a minimum or a maximum?
Minimum.
Okay. What is the domain?
All real numbers.
Good. What's the range?
Negative.
Negative 3. Which symbol?
Less than. Greater than.
Greater than or equal to when it's a minimum. Good. What's the axis of symmetry?
Negative 3 over 2.
X equals negative 3. Now, when it only hits it one time, it's just that number.
Oh, so you don't have to divide by 2?
No, only when there's 2,
All right.
because you're trying to find like the middle,
Oh, okay.
and this is it itself. Good. All right, next one. What are my zeros?
Okay, ready?
Yes.
4.
Yes.
Negative 2.
Beautiful. Those are the zeros. All right, next. What is the axis of symmetry?
Negative 2. No. Is it negative 2?
It's 1.
Beautiful. X equals 1. Because if I add 4 plus negative 2 and divide it by 2, 2 divided by 2 is 1. Or the other way is to find the vertex, which is right here, and it's the order pair 1, 4.5. And again, the axis of symmetry is this thing, x equals 1.
This
Yes.
English class, but you spelled zeros on it.
Sorry. All right, I take off an E. No E, just S? Okay. That looks weird. Okay, so zeros. All right, next. Another one. Okay, finding the axis of symmetry by using the formula. Okay, so before, to find the axis of symmetry, you were given a graph. Now you may only be given the formula or the equation. So the formula to find the axis of symmetry is negative b over 2 times a. Again, remember your equation is in this form, standard form, ax squared bx plus c. So we're going to take the number in front of x squared and in front of the x, and we're going to use that in this formula. Negative b over 2 times a. They have the negative sign out front, but basically make b opposite sign and then multiply 2 times a. Let's see this in action. So here is my equation. My a equals negative 3. My b equals 10. Everybody see where I'm getting these? Right here and right here. Here is my formula. Negative b over 2a. b is positive 10, so I'm going to now make it negative 10 over 2 times negative 3, and I get negative 10 over negative 6. I need to reduce. I can divide them both by 2, and it becomes 5 over 3. Again, axis of symmetry is an equation, so you need to put it as x equals. Yes. Yes.
So what would be the vertex then?
Okay, so, and we're going to learn that coming up, but just to give you a preview, once you find the x, remember the vertex is in order pair. So what we're going to do is you would take this and you would plug it back into your equation to find the y. So for example, you would do negative 3 times 5 over 3 squared plus 10 times 5 over 3 plus 9. And then follow order of operations. Once you get this, because this is y equals, and that would give you the order pair. So that's where you're going to find the vertex.
I'm confused on how to use the equation.
How to use the equation?
Yeah. Or how to do it.
Okay.
Equation.
So, again, the equation is this. Y equals negative 3x squared plus 10x plus 9. Remember, standard form is y equals ax squared plus bx plus c. What we need for the axis of symmetry is the a and the b, because the formula is x equals negative b over 2 times a. So I'm going to pull out my b. So let's first just identify my a equals negative 3 and my b equals 10.
It might be.
I'm sorry?
I got confused. It might be or it might be.
What?
Be.
Okay, so now x equals negative 10 over 2 times a, and then I get negative 10 over negative 6, and then I have to simplify it to 5 over 3. And again, it's x equals. And I'll do another example in a minute. You ready? Next one. Here is my equation. Let me rewrite it. Y equals 2x squared plus x plus 3. My A equals 2. My B equals 1. My formula to find the answer, the axis of symmetry, is x equals negative b over 2a. My b is positive 1, so I'm going to make it negative 1. My a is 2, so I get negative 1 over 2 times 2, which is 4. So negative 1/4, so my axis of symmetry is negative 1/4. Yes.
So that would be our answer?
Yes. So this is when you don't have a picture. Yes.
If we divide it, are we supposed to?
If you what?
If we do divide it?
Like to a whole number? Yes.
Yeah. And then would that be the vertex? Or would
That would be the axis of symmetry and the x of your vertex.
Okay.
Once you plug it back into the equation to get the y, then you would have an ordered pair.
Okay.
Yes.
I don't get what's the negative.
Okay. So basically, this negative sign is really saying opposite of what b is. So if b is positive 1, when you write it in the equation, it becomes opposite of positive 1, which is negative 1. So think of the negative sign as not necessarily negative b, think of it as the opposite of b. No? All right, let's see if there's another example next. All right, let's say we have this equation. Y equals 2x squared minus 3x plus 4. Okay, my A is 2. My B is negative 3. I'm now going to take the equation opposite of B over 2 times A. So opposite of B would be positive 3. And then 2 times this A is 2 times 2, and you get 3 over 2 times 2, and my axis of symmetry is going to be 3/4. That better? Yes.
Does A have to be the first letter on the
Yes, it must be in standard form. So it's got to be with the x squared, then the x, then the number. So if your equation is not in standard form, you must rearrange it first. All right, let me just make one up. Okay, so here, now it's actually telling us how to find the vertex. And I already gave you a little preview. Once you find the axis of symmetry, then you're going to take that number, plug it back in, substitute it in for the x, and follow order of operations. So for example, and we got some decimals here, but we have this equation. Y equals 0.25x squared plus 2x plus 3. My A value is 0.25. My B value is 2. I'm going to follow and do the formula. So I'm going to do x equals opposite of B over 2 times A. And then once I do that, I'm going to get negative 2, and 2 times 0.25 is 0.50. I'm going to divide this. I can't leave a decimal in my fraction. So I can either move my decimal point once and move it once, and now it's negative 20 divided by 5, and my axis of symmetry here is negative 4. Now, if you'd rather leave it, the negative 2 over 0.5, and divide it that way, you move this once, move this once. So then it's negative 20 divided by 5, and you still get the negative 4. So my axis of symmetry is negative 4. To find the y of my vertex, again, I'm going to take my original equation, 0.25x squared plus 2x plus 3. I'm going to replace the x with negative 4. So So I'm now going to do 0.25 times negative 4 squared plus 2 times negative 4 plus 3. I'm going to square it and get 16 plus negative 8 plus 3. 0.25 times 16 is just 4. And then I have the plus negative 8 plus 3. I'm going to work left to right now. Negative 4 plus 3. And then I get negative 1. So now my vertex is what I got right here and what I got right here. So negative 4, comma, negative 1. Find the axis of symmetry of this. And let's say it's 6x squared minus 3x plus 4. Again, you're going to first identify your A, identify your B, and now we're going to put it into negative B over 2 times A. So negative B, opposite of B, would be positive 3 over 2 times 6, which would give me 3 over 12, which would simplify to 1/4. So my axis of symmetry is 1/4. X equals.
Oh, so finding B, negative B over 2 times A is the same thing as finding the axis of symmetry.
Yes.
Yeah, I got those mixed up.
Okay. Okay. This also is the beginning of our vertex. Remember, the vertex is in order pair. The axis of symmetry is the x of our vertex. Then to find this y number, you plug this back into the beginning for x. And that gives you the y of the vertex. And that's what we just did. Okay, let's see what else is here. Find the vertex. Here we go. So again, we're going to do axis of symmetry first. So our A is negative 3. Our B is 6. Our formula is negative B, or opposite of B, over 2 times A. So here, my B is positive 6. So when I put it in here, it's negative 6. And then 2 times negative 3. And I get negative 6 over negative 6. I need to divide this and make it x equals 1. I now have my axis of symmetry. And I also have the beginning of my vertex. So I have 1. And now to find the missing piece, I'm going to take this 1 and I'm going to plug it into the original equation. So let me write the original equation over here. I am now going to take out all of my x's, and in place of them, I'm putting in a 1. So then negative 3 times 1 squared, did I say negative 1? It's positive 1, plus 6 times 1 minus 7. 1 squared is 1. 6 times 1 is 6. And then I'm going to multiply negative 3 times 1. And now I'll work left to right. Negative 3 plus 6 is 3. Minus 7 is negative 4. So my vertex is positive 1, negative 4. So you need to just memorize that it's negative B over 2A, or opposite of B over 2 times A. Get the x, plug it back in. Here is where they finished it off. And they did the same steps that I just did. Let's try another one. We have the equation y equals x squared minus 4x minus 10. Again, my A is 1. My B is negative 4. My formula is opposite of B over 2 times A. Opposite of B is now positive 4 over 2 times 1, 4 over 2, and my axis of symmetry is x equals 2. But it didn't ask for the axis of symmetry, it wanted the vertex. So now again, I take my original equation, I'm going to take out the letter x's, and I'm going to put in 2's. So 2 squared minus 4 times 2 minus 10. Square the 2, multiply this here, and now work left to right. Negative 4 minus 10, and the y of my vertex is negative 14. So the ordered pair for my vertex is 2 comma negative 14. So it's just a process. And again, the best way to practice it is to do a lot of problems. The second slide has it finishing the problem. Here is an application. It says the graph that's listed there can be used to model the height in meters of an arch support for a bridge, where the x-axis represents the water level and x represents the horizontal distance in meters from where the arch support enters the water. Can a sailboat that is 14 meters tall pass under the bridge? So you know that the vertex is going to be the highest point. It's the maximum. And then from there, we're going to find that vertex by doing negative b over 2a, and then plug it back in. So here, the maximum, remember, is our y value. And since the height is 11.76, that sailboat can't fit. You're going to see questions like this on the SAT. A lot of quadratics model, like balls being kicked into the air, or a water fountain and the motion that the water makes. These are all good examples of real life applications. Here's an application with a roller coaster. You can go ahead and read through it and follow the steps for solving this application problem. So your homework is practice A tonight.